Hello Chemistry 10H students, this is Mrs. Altman, and in this video I am going to review how to determine how many significant figures that there are in a measurement. These are the same notes from class in case you need them, but I'm also using them to sort of recap the concepts. So the first thing that we need to understand is that everything that is measured will be significant, whether it is a certain or an uncertain digit. Everything that is not measured, which will be a 0, are not significant. And the more significant figures that you have, the more precise your measurement is. And when I say more precise, that means more reproducible, or it can also mean that you are using a device that has a smaller range of error. So you're using, for example, a ruler with lines every millimeter rather than something that only has lines every decimeter. All right, and then here are the rules for counting significant figures. I'm going to give an example for each rule. So the first is that all non-zero digits are significant. So before I actually get into this example that we're going to do in a minute, I will list some examples of this. So 5532, everything there is not 0. So this has 4 significant figures. I'm just going to abbreviate it to SF. I may even say sig fig just to make things faster. So anything that is not 0 is significant. If something is a 0, it is going to depend on what type of 0 that it is. And there are 3 types of classes of zeros, and then one of those types has sort of 2 rules associated with it. So really 4 types. The first is that there are leading zeros, and these are not significant. So 0.00055595. All of the zeros leading up to the 5s are leading zeros, and they are not significant. So this has 4 significant figures. The second type of 0 is a captive 0. So let's say I've got 5,005. Because those zeros are sandwiched between significant figures, they are also significant. And so this has 4 significant figures. Then there are 2 types of trailing zeros. So you could have one after a whole number. So let's say I've got 55,000. These are trailing with a whole number. So this is 2 significant figures. Those 3 zeros are not significant. And then there is trailing after a decimal. So let's say I've got 1.000. This is 4 sig figs. And then you can also have combinations where you've got different types of zeros. So for example, I've got 0.002050. So in this, my first 3 zeros are not significant because they are leading. The 2 and the 5 are significant. The 0 between the 2 and the 5 is captive, so it is significant. And the 0 at the end is trailing after a decimal, so it is significant. And this is 4 significant figures. Now I'm going to work through some examples rather slowly so you can see all of the different ways that this can manifest. So this is different from the examples that we did in class, and let's walk through them. So the first one we have is 400. I'm using the sort of whiteboard feature so I can do a check or an X over each one and each digit and explain it as I do it. So 4 is obviously significant since it's not 0. Both of these zeros are trailing after a whole number, so they are not. So this has 1 significant figure. Next, I've got 400 with a bar over the second 0. So just as a note, and I will type this for a second, a bar over a 0 means it is significant. You can also represent this with a dot, but that only works if the 0 is in the ones place. So 4 is significant. This 0 is significant only because there is a bar over top of it. And then I have a trailing 0 with a whole number. So it is not significant. So this has 2 sig figs. Next, I have 400 with a dot at the end. So the 4 is significant. And then I put a dot after it to show that this 0 is significant, which makes this one significant. So 3 sig figs. Next, I have 4.0 times 10 to the third. I'm going to add a little note here. I've probably said it in class, but it's always worth it to say it again. Everything in scientific notation, aside from the power of 10, is significant. So I could just look at this and tell you it's 2, but I'll still explain why. So 4.0 times 10 to the third. So we don't care when we're figuring out sig figs what the power of 10 is. Everything in scientific notation is significant. Another way you could think about it, that 0 is trailing after a decimal, so therefore it is significant. For next one, 4.0 times 10 to the negative third. Same thing. It's in scientific notation, so everything is significant. Oh, I accidentally gave it an extra 0. All right. So my 5 and my 2 are both significant. The zeros in between them are captive, so they are significant. And then these are trailing after a whole number, so they're not. So that has 4 significant figures. Right, so the zeros here are leading, because there's nothing before that decimal, so they are not significant. Then everything else is, so this is 3 sig figs. Right, so the 5 is significant, the 1 is significant. Now I have to worry about the zeros. The first 3 zeros are not significant because these are leading zeros. This one between the 5 and the 1 is significant because it is captive. And then the ones after it are trailing after a decimal. So those are significant. So I've got 5 significant figures. And then the last one for this video. So the 5 is significant. This 0 at the end is significant because it is trailing after a decimal, which makes these 2 captive. So I have 4 significant figures. So I hope this was useful. Thank you so much for watching and have a great night.